So the first thing to do in your lab is to do your MCQ. So go to Canvas, MATH7016, quizzes MCQ 0 and take your MCQ. It's important. It'll give you a good signal for how you're getting on. So we have a few exercises here in this lab. So the first one is you've got some physical process, and you've got big T as a function of little t. So this is like y is a function of x, and the x goes in the first column and the y goes in the second column. So you should have a t, little t, and a big T. And we want the t's to go from 0 to 60 in steps of 1. So you're doing 1, 0, 1, and go down to 60. And then in the t column, the y, as it were, so you want this to depend on this. Now you could do like 20 plus 80 times exponential of minus 0.07 times t and put in the 0, but that's not really what you're going to want to do because that won't be draggable. You should put in here a2, which I can't touch here just because it's blocked. So I'll just put it in myself, and there's somewhere to go from here. In the next question, you want on one graph. Now it is possible to kind of produce, xw, say xv, xm, and kind of put them all together. But actually, Excel is just about smart enough to understand that if you have an if you have a variable here and then maybe 3 more like this, it does actually understand that if you're to select all of these like this, it understands that this is the x variable and these are 3 different y variables. It's kind of understood as a default, as it were. So this is a similar one. It doesn't really say what steps to go in. It just says you're going from 0 to 6. So you can kind of choose that for yourself. So the next task that we're looking at is we're kind of moving into VBA. Now, typically from now on, we will be using insert ActiveX button, but just for this section here, we won't actually do it. It'll actually mess us up a little bit. So what we're going to do is we're going to take this code. I'll see if I can copy paste it, possibly not. So I will do developer. I'm not sure exactly how to see the code here. I can probably get into it in here. I'm just going to put it in. I know that Declan would have done a lot of modules. We typically will be working behind the sheets, something like this. Now, I'm going to actually just change something while we're here. So I'm going to change this to this. It'll just help us a little bit later. So your job here is to correct this code, and so I recommend deleting that length equal to 1. Length equal to 1 is the initial value of the length, it says it here what to do with it. So once you've that code written down, to find out what's wrong. Now you could look at it and figure out what's wrong, but what I want you to do is use F8. So split your screen between Excel and VBA, and a great way to debug is to execute the code line by line, and it also will help you understand your code. So you literally just press F8 here, and it goes through it line by line, and it'll help you, and you can kind of predict, and you can hover over things. So for example, if I do F8, here I can see that R is equal to 1. And here I can see that A, for example, is equal to 0. I think I was supposed to put the value of A in here, but we'll get back to that. So that's your debugging setup. So we're on sheet 4 here. This, am I going to be, oh yeah, very good. So this here is going to be plotting with parameters. So this is kind of looking towards something that we'll be doing later. It has one problem with it, which we'll get to. Okay, so we've got a differential equation. It's got an exact solution. Now the parameters, you've got the environmental temperature, a heat transfer coefficient. We also have initial temperature. that's not really a parameter. That's just the initial value of the temperature. And typically, you shouldn't really have the initial value of a variable as its own variable. So we're going to have a temperature variable, but you shouldn't also have a temperature initial variable. Okay, and then there's going to be a step size. So we have been going in steps of 1. This is talking about steps of a variable 1, and then a final time. So we'll set up our little dashboard. We'll refer to this as TE or initial temperature, step size, and T final. So I'm going to do a little bit of making it look lovely. Okay, and sure, we'll just chuck a bit of, if it's handy, it may or may not. No, we'll just leave that off. It sounds small. Okay, so I'm going to put in some values. So suppose the environmental temperature 20, this heat transfer coefficient of 0.07, initial temperature of 100, step size say 0.1, and a final time of 60. Okay, so what we're going to, the point of this dashboard is we're going to do developer insert ActiveX control this button. Oop. What we're going to be able to do is, so we're going to have a problem and we can change the parameter. So maybe the initial temperature is 100, now we want to see with 90, and rather than having to go into the code, we can simply just press the button. So this is kind of the point of this. Okay, now we're going to, behind your command button, so it's behind this, we're going to define some variables. Now I can get in there like this. This is now in the wrong place in terms of over here. Okay, so what if we do the debugging correctly, we may have discovered something wrong with this, or something maybe, yeah. So this HT, people probably, if you did this, you probably wrote it correctly, but it's actually the spelling error is correct, as in the spelling error is supposed to be there. And because this isn't declared as a variable, and well, no, excuse me, because it's a spelling error, and the wrongly spelled thing is not one of the variables, it's just going to be treated as a 0. So the length is always going to go to 0 plus 0.1. The length is just going to stay with this. And the way you get around this is you put what's called option explicit. Now, if we try and run this thing, I think even line by line with F8, we get variable not defined. So from now on, you would be recommended to always use option explicit. So we'll do that up here. It is a bit bigger. So we're just going to plot a function here where there's different things. Option. Oh, it's just like that spell. Okay, so let's go back where we were. So we're in this scenario. So all of these things are different variables. So we want different variables. We want a time variable, a temperature variable. That should also be a double. A heat transfer coefficient variable, an environmental temperature variable, H a variable, a final time variable, and a counter. Now the counter is different to the others because it's an integer and it's actually going to count the rows. So let's just call it row. So you must also do all the other ones. So like dim t as double, dim, you won't be able to do big T, so maybe temperature as double, etc. Okay, and you're going to do the rest of them yourself. Now, the way our programs are going to work is you define your variables and then you give them initial values. So time for us is always going to start at 0. Temperature is going to be the initial temperature is going to be taken from the worksheet, and so from the dashboard. So this is row 2, column 6. So this is going to be cells row 2, column 6. So that's the initial temperature. And the row, well, what we're going to have is we're going to have time here and temperature here. So the initial row that we're going to work in is 2. So the initial value of the row is equal to 2. Okay, so that's define your variables, give them initial values, and then you're going to have a do loop. Now the basics of a do loop are do stuff and then loop until. Occasionally you'll want to put the do until at the start, or do while at the start, or you want to do loop while at the end. I think typically it's better to do the condition at the end. So, okay, we're going to produce values of t, time and temperature in columns A and B. Now I'm going to write a do loop. It's going to print the current values of t. So it kind of says it there. So to print the times into column 1 when you're in whatever row. So the very first go of this is going to be in row 2, column 1 equal to t. You're also going to print the time, the temperature, and then you're going to calculate the next values of time and temperature and counter. So what happens to the time? Well, the time is going to go up by the step size, and I'll let you worry about the next temperature, the next counter, and keep looping maybe until the time is bigger than the final time. So we're going to keep going until time is bigger than final time. Final time hasn't been set up yet. And this should work. It should give you the same output as before. If we go back here with 100, maybe the first time you run your code, this is saving. Oh, it's not saving automatically. I think the saving automatically. Oh, it was. Saving automatically is a good idea, because if you crash and you haven't saved, you can be gone. I'm going to do a little bit more here, I think. So we'll dim h as double. Dim, I'm also going to need tf as double. Everything should have initial value. So h is coming. This is cells 2 row 2 column 7. And then I want tf, I think, is in the next one over, cells 2, 8. And if the first time I run my code, rather than F8 and maybe it crashing, I can do line by line with F5 and pressing play or whatever, seeing it crashing. So here actually straight away you can see there's an issue in that I should be going down the first column, but the row isn't changing, so I have to put the row up by 1 each time. I'm probably doing too much for a setup. Yeah, I'll let you kind of finish it from here, even though the most of it is actually done. My apologies. The if statement. So, as I said, the stopping rule is quite crude. So with this setup, pretty much the temperature is equal to 20 all the time. And so maybe you should stop when the temperature is within 1 degree. So put an if statement in the do loop once the distance between the temperature and environmental temperature is less than 1. So all I'm going to do for you is just the pseudocode. So maybe when you get down to here, if, and I'll just write the pseudocode, if condition, and if the condition is true, then do this stuff, and then end if. Now the stuff you want to do is given there. It's exit sub. So you'll stop. You'll go to the end of the whole thing. Really, you're just finishing the loop, but when you finish the loop, you finish the whole thing. Okay. Now, if you really want to beef up your program, recording macros can be extremely useful. What I mean by kind of beefing up, I suppose beefing up is making it more solid as such, but I'm actually talking about kind of some finishing touches actually, which isn't beefing up. So anything you can do in Excel, like coloring cells, selecting, copying, pasting, inserting graphs, can be put into VBA code using the Excel macro recorder. That's this yoke here. Okay, so I'll just kind of show. We'll kind of show this with an example rather than doing the thing. So rename macro recorder. Right. So let's see how this works. So with the macro recorder, you might select everything in columns A and B, which you do like that. delete everything in A and B, you press the delete button and then put in new T and T labels, for example. And then you could talk about, this is probably going back to this plotting with parameters, to be honest with you. So let's go back. Yeah, so I want to record a macro that basically will delete the previous running by selecting here, deleting, put in T and T, and then I'm going to put it, yeah, and then I'm going to stop the recording. So let's just see how this works. So record macro, macro 1. So everything we're doing now is going to be recorded. So select everything columns A and B, delete by pressing the delete button on your keyboard, put in the new labels T and T, and then it doesn't really matter where you go now, and now press stop. Now there are two, oh, this is interesting, I haven't seen this before. Save script. I think you'll probably have to do that because what the hell? I don't want it there anyway. Don't mind what that yoke is doing. I'm sure it's useful, but I'm kind of going slightly older school. The code is recorded in a module here. Now you can either copy and paste this code directly into your code. So like maybe at the start, before you do anything, you delete the previous running. The reason is that we will want later to run a program multiple times and maybe plotting everything that's in here. And what might happen is we might go for a smaller time. And if we don't delete the previous running, we'll get a graph that is a mixture of old and new data. And you don't want that. So doing this is a good idea. Alternatively, to copy pasting the code, you can just call macro 1. And again, if you want to see how the code works, F8 to kind of do it line by line. So line, call macro, it's going into the module. It's going to select columns A and B, watch it. On the left, it's going to clear them. It's going to select A, it's going to put in a T, select B, put in a big T, and then basically nothing. Then, okay, it's going to run off and do its thing, and look at it go there. That's great. I'll just stop it there, and you can see that if you were to run it again, you'll see that this previous running will get deleted if I do the call macro. It selects, does all this for me, and then I kind of go off again and do it. So that record macro can be very useful and great fun. Now, saying stuff about a graph, to be honest, that can be a little bit dodgy. Wouldn't worry about it so much. It can just lead to a thing, because if you keep trying to graph, or if you did a macro to select data and graph and you did it inside every loop and you did 1,000 rows, it would like end up with 1,000 graphs, your file is going to collapse. So there's a little bit of code there if you did end up with loads of graphs on your thing, what to do. And there's finally an exercise. So this will be our exercise. We're doing what we did earlier. Remember the X, W, V, M, and we are taking, say, the length, the W0, which is a load period length and a step size from a dashboard, and doing kind of what you did previously. So you mightn't be able to do this until after you've successfully done the previous thing. So this is hopefully to set you up. Give it a go now. And if you're still stuck, you can watch the next video where I finish all of these off.